So welcome again to another session of everyday mathematics. And today we go straight into the topic of trigonometry. So we'll start again on the MIT 2023 Integration B qualifying exam, build up to the regular season, quarterfinals, semifinals, and finals again. So in the qualifying exam, we'll tackle problem number 6, which is the integral, indefinite integral of x plus sine x plus x cosine x plus sine x times cosine x. Then we'll also look at problem number 7, which is sine x squared plus cosine squared x plus tan squared x plus cotangent of squared x plus sec squared x plus cosec squared x as our integrand. Again, an indefinite integral. Problem 12, an indefinite integral of sine at the power 6 x plus cosine power 6 x plus 3 sine squared x times cosine squared x. Problem 16 is our next problem, which is 3 times sine 20x times cosine 23x plus 20 sine 43x. And problem 18 was the last problem with trigonometry functions or trigonometrical functions in them, which was sine x over 2 e to the power x plus cosine x plus sine x. Again, a quick reminder to those who are here and haven't yet subscribed for the second or third time, and also for our new visitors, we highly encourage you to subscribe to our channel so that we're able to send you that quick notification whenever there is a new video that's uploaded, but also it gives us that extra visibility. Yeah, thank you so much. So going straight to problem number 6, which is the integral of x plus sine x plus x cosine x plus sine x times cosine x. So this can be spread out into the 4 different integrals so that we can integrate these different terms independently. We could integrate x sine x, x cosine x, sine x cosine x independently. So the integral of x is the same as x squared plus over 2 plus a constant. The integral of sine x is negative cosine x plus a constant. Integral of x cosine x, we can take advantage of the product rule here, where we assume that x is our v and u is our du dx, such that we have the product of v and u here. If du dx is cosine x, then u is definitely sine x. Therefore, the product of u and v is x sine x minus, and then here now we have the product of dv dx times u. So dv dx, v being x, dv dx is 1, so we have the integral of sine x. So this is integration by parts, and therefore the total integral becomes x sine x plus the integral of sine x is negative cosine x, so the negative sign and this minus sign cancel out, so we have a positive sign, so it's x sine x plus cosine x, and then a constant. And then lastly, the integral of sine x cosine x, we can combine sine x cosine x into half of sine 2x, and therefore the integral of sine 2x is a half of a quarter cosine 2x. And then we can now expand cosine 2x and express in terms of single angle. So we have cosine x being 1 minus 2 sine squared x And so plus c here. Then we have a constant here. A quarter times 1 is negative 1 over 4. So we can bunch the constants together. And so we have the answer being 2 over 4, which is a half of sine squared x plus c. So summing up every little component or term that we use in the integration, x sine x, x cosine x, and sine x cosine x, we get that to be x squared over 2 minus cosine x plus x sine x plus cosine x plus a half sine squared x plus all the constants summed up together into a bigger constant. And so the negative cosine x and positive cosine x cancel out. And so we have x squared x over 2 plus x sine x plus a half of sine squared x plus a cosine. So this is our answer. We could also just expressed in a more compact fraction where we have now x plus sine x squared over 2 plus c as our final answer. Then down to problem 7, the integral of sine squared x plus cosine squared x plus tan squared x plus cotangent of squared x plus sec squared x plus cosec squared x. So as you can see already, for those of you who know this identity, these first two terms add up to 1. So we have the integral being equal to 1 plus tan squared x plus cosec squared x minus 1, and this identity here comes from cotangent or cot squared x, is equivalent to this, and then sec squared x plus cosec squared x. Now, as you might also realize, 1 plus tan squared x is the same as sec squared x. So we have sec squared x, another sec squared x there. We get 2 squared x, and then we also have 2 cosec squared x. So those also add up into 2. Now, we know very well that the derivative of tan squared, the derivative of tan x is sec squared x. So the integral of 2 sec squared x is 2 tan x. And we also know that the derivative of cotangent is cosec squared. So the integral of cosec squared now is going to be cot x. And so we have 2 cosec squared x resulting into minus 2 cotangent. Sorry, I've forgotten to mention that derivative of cotangent x is a negative of cosec squared x. So and also the negative 1 or the minus 1 now results into a minus x as the integral plus a constant. So that's the answer. That was a short problem. Next, problem number 12, which is the integral of sine to the power 6x plus cosine the power 6x plus 3 sine squared x cosine squared x. First thing I would do is we know sine squared x plus cosine squared x being equal to 1, and then if we cube that, that results into sine to the power 6x plus 3 sine to the power 4x. This is more or less a binomial expansion, plus 3 sine squared x cosine squared x plus cosine squared x. So all this is still equal to 1, and then if we arrange things so that we have sine to the power 6x plus cosine to the power 6x on one side, we have 1 minus 3 sine to the power 4x cosine squared x minus 3 sine x cosine to the power 4x, right? And so the integral now of sine to the power 6x plus cosine to the power 6x plus 3 sine squared x plus cosine squared x is equals now to 1 minus 3 sine to the power 4x cosine squared x minus 3 sine squared x cosine to the power 4x plus this 3 squared x cosine squared x. Now, rearranging this around such that so that the positive comes here first, and also adding up with this term here, we can pull out 3 sine squared x cosine squared x, and so we are left in bracket with 1 minus sine squared x. And we know from the identity here of sine squared x plus cosine squared x equal to 1, this now implies that this term in bracket is the same as cosine squared x. So multiplying cosine squared x by this cosine squared x, we get cosine to the power 4x, which is now means that this entire term is the same as this entire term after the negative sign. So essentially these two terms cancel out. And so we have this term here and this term cancelling out. And so we are left with the integral of 1. And so the answer is x plus a constant. Now down to problem 16, which is 3 sine 20x cosine 23x plus 2 sine 43x. We're going to use the sum of angle. So the sine A plus B is the same as sine A cosine B plus sine B cosine A, and sine A minus B is equal to sine A cosine B minus sine B cosine A. So when we add these two together, we find that sine A cosine B is equal to a half of sine A plus B plus sine A minus B. There's another bracket here that I forgot. Okay, and therefore sine 20x plus cosine 23x is the same as half of sine 43, because we're adding 20 plus 43, plus sine of 20x minus 23x is negative 3x, which is the same as, because the negative sign here propagates outwards, and so we have a half of sine 43x minus sine 3x. So we can now plug that into the integral sign, and so we get the result being that we have now 3 over 2 sine 43x minus sine 3x plus 20 sine 43x. Now adding this and this means that we have 43 over 2 sine 43x minus 3 over 2 sine 3x. So if we integrate this, it means that now we have negative a half of cosine 43x plus a half of cosine 3x plus c. Now this can be expanded as negative a half of cosine 23x plus 20x plus a half of cosine 23x minus 20x, which when we expand out is the same as cosine 23x cosine 20x minus 23x times sine 20x, the negative half outwards, plus a half of cosine 23x plus times cosine 20x plus sine 23x sine 20x plus a constant. So this negative here propagates inwards, and so this term here and this term would cancel. And since this negative and this negative here means that this term becomes positive, so half and a half results in us having 23x sine 23x times sine 20x plus a constant being our answer. Okay. Now, lastly, problem 18. the integral of sine x over 2e to the power x plus cosine x plus sine x. Sine x over 2e plus cosine x plus sine x, it can be expressed as a half of 2 sine x over 2e x to the power x plus cosine x plus sine x. Now, whatever is in the bracket can also be expressed as 1 minus 2e to the power x minus sine x plus cosine x over 2 e to the power x plus cosine x plus sine x, right? Now, it means that if we integrate this new expression, it means that the first term here can be integrated as x, and the second term here can be integrated as log of the denominator, natural logarithm of the denominator. So our integral now is a half into bracket x minus log of 2e to the power x plus cosine x plus sine x plus a constant. So that is our answer. This is our answer. And that marks the end of integral of trigonometric functions. I think these problems are pretty tractable and could be solved within the allotted time. Again, a quick reminder to those of us who are looking at these problems and visiting our channel for the first time or are here for the second time but have not subscribed, to please hit on the subscribe button. Thank you so much, and we'll see you again when we solve the next set of problems.